class. This is Coach Brown. We're going to look at probability in this lesson. We're going to leave out counting this time. I felt like counting was something we probably needed to do together. There's a lot of nuances, a lot of whatnots and what have yous to permutations and combinations and when to use each. That isn't necessarily something we can just write down as a note. So we're going to put that off to the week after next. What we'll do next week is we will get together. We'll actually meet in class. This is July the 9th we're talking about. We'll meet in class. Then we'll do systems of equations and matrices. Then the next week we'll review, have our quiz, and then we'll talk about permutations and combinations. And then that next week will be our final exam. So this week we're just going to do probability, and then you'll have an accompanying homework set of questions that will go along with it. Won't be very long because, as you can tell, if you've already got the notes pulled up from your email that's attached to your email, you'll know that it's not very long. So for probability, the first thing we want to look at is that there are two types of probability that we'll need to differentiate between. The first kind is called empirical probability. And so empirical probability, let me write that down, is actually observed probability. And so what we mean by that is that this would have to come from an experiment of some kind where we would actually sit around and flip the coin and roll the die, or whatever particular context we're looking at. Empirical probability is observed probability that we can find. We're going to look at that here in just a second. The other kind is theoretical. And theoretical probability is where most of us take our minds when we speak about probability. Because the probability of, say, flipping a quarter, you have heads and tails. And the notion is that if we flip the quarter however many times, it doesn't even matter, that half of the time it should land on heads and the other half it should land on tails. The truth is, however, that may not happen. We could flip the quarter 100 times and land on heads 75, and in the other 25 we land on tails. Well, that doesn't match up in theory, but the theory says it should be 1/2. So to compare that example, say we took the quarter, we flipped it 100 times, 75 times it landed on heads, and 25 times it landed on tails. Well, the empirical probability for that particular simulation is that 75 out of 100, or 3/4 of the time, the quarter landed on heads. Whereas the theoretical probability is, what is the theoretical probability that the quarter lands on heads? It would be 1/2. So again, theoretical and empirical may not necessarily match up. Now, there is a notion in math, it's called the law of large numbers, that says theoretical and empirical will eventually match up, but you have to go out to a ton of simulations. So that would mean flipping the coin 1,000,000 times, or 2,000,000, or 1,000,000,000 times. And the law of large numbers says is that the more times we flip, we get a large number of simulations, the closer theoretical and empirical probability should be. Will they ever come together? That's a discussion involving infinity, obviously. However, empirical and theoretical probability do exist. They have their own applications. But for us, from here on out, after we do these first two examples, we're going to assume that when we say what's the probability, that we're talking about theoretical probability. Because empirical probability actually has to be measured. And for us, we're not going to do that. We're going to look at all these as theoretical notions, these ideas and examples that we have here. We're just going to assume that they're going to be theoretical. So the first two we're going to look at and actually calculate some empirical probabilities. Again, you're going to be asked to do this on your quiz. You're going to be asked to do this on the final exam. So we need to be able to do it. So what you have here is just a frequency chart. It says 2 coins are tossed 20 times and the number of tails is observed. The outcome, the 3 possible outcomes that you have there, 2 tails, 1 tail, and 0 tails. And then it asks us to compute the empirical probability. So again, if they want empirical probability, they're going to actually ask for empirical probability. Okay, so They want to know what's the empirical probability that exactly one tail occurred. So one tail is right there. The empirical probability is 0 out of 20. 20 is the total number of times that it was tossed, or total number of simulations, and the number on top is number of successes. 0 divided by 20 is 0. That means that it did not happen. Okay, if we were asked the probability that 0 tails occurred, then that would be 19 out of 20. Now we know, just using a little common sense, that this particular frequency chart is realistic. This could happen if you flipped a coin 20 times, or excuse me, two coins 20 times. So it doesn't necessarily match up with theoretical, but again, we're calculating empirical probability. Okay. The second one is a spinner. You'll see that quite a bit in our notes this week. It says the spinner spun 36 times. The spinner landed on A 1 time, B 4 times, and C 31 times. And of course, looking at this spinner, half of it is A. You would expect that half of the time when you spun the arrow or spun the arm that it would land in A, but that's not how it happened here in this particular simulation. Compute the empirical probability that the spinner will land on B. So for this particular simulation, it landed on B 4 times, and it spun 36. So this is going to be 4 over 36. I always want to reduce our fractions. This is 1/9. And so empirically speaking, 1 out of 9 times this the spinner lands on B. We know that not to be true because this doesn't even work out to be in ninths, but that's the way it particularly happens for this example. Okay, so this is empirical probability. Empirical probability is going to require actual numbers for you to actually calculate the probabilities. Theoretical will not have that. Okay, so all you're going to be asked to do with empirical probability is just to be able to identify it and to be able to calculate those, but you'll have to be given some information about those.